Good afternoon, everyone. This is Professor Keen. This is probably my final lecture on Pascal. We'll see if I can get everything I want to say done in one lecture or if I have to break this up into two. But what we'll be doing is talking about Chapter 18 of A Student's Guide Through the Great Physics Texts. And this is where Pascal asks, does nature abhor a vacuum, or does nature hate a vacuum? And I guess this raises a more general question, which I'll maybe just throw out right now before I go into some of the details of what Pascal is saying. But more generally, can nature act in such a way as to achieve goals or ends? Is there some kind of telos or end or purpose in nature? That is there sometimes the word entelechy is used. Is there an end or purpose built into nature? And Pascal believed that nature, being inanimate, cannot have goals or desires or ends. This is on page 231 of A Student's Guide if you're interested in taking a look at the surrounding text. It's actually a very interesting chapter, so I'd recommend you highly to read through this. And so that's Pascal's position, is that nature, being inanimate, cannot have ends or purposes. But the difficulty is, obviously, there are some things in nature that do have ends or purposes. After all, we, human beings, are parts of nature, right? We are animate. We have ends or we have goals. So, for example, my goal here is to explain Pascal's ideas to you. So that's my goal, and I'm acting on that goal. And insofar as I'm part of nature, then nature must have ends or purposes in it. At least parts of nature do. So the question is, what part or parts of nature is it valid to talk about as having purposes or ends, and what parts do not have purposes or ends built into them? And there have been many different thoughts on this throughout history, and so we'll come back to this more general question shortly. Now, what's the context in which Pascal brings up this issue? And it has to do with explaining certain kinds of observations about nature. So, for example, it is difficult to open up a sealed bellows. So if you have a bellows, like what we've talked about this, what you blow on a fire with in order to help it burn brighter. If you seal up the bellows, it's very difficult to open it up, right? And what the Aristotelian argument was that, well, nature abhors a vacuum. Nature acts in such a way as to not allow this vacuum to be created inside of the bellows. And that is precisely why it's difficult to open the bellows. And that's also why, for example, a suction cup is hard to lift off of a surface. And it's because in so doing, you would have to create a vacuum underneath it. Nature abhors a vacuum. And thus, that's why it's difficult to lift a suction cup off of a surface. Pascal, on the other hand, argues that it's not at all because nature abhors a vacuum, but rather because of the weight of the air. So what I'm going to do is I'm going to kind of flip back and forth to a screenshot here. So let me draw a picture to help explain what Pascal is talking about. So he argued in this way. He said, suppose that you have a long glass tube. And this is a bit of review from one of my earlier lectures. A long glass tube that has a bellows on the end, like this. So here's the bellows on the glass tube. Let me open up my coloring board here. So, and let's suppose this is the ground. And let's suppose that we were to take this bellows and put it into a pool full of water. So this is H2O, this is water. So maybe I'll draw some lines here to indicate that this bellows and this glass tube are completely surrounded by water. And then up here, you have air. So I'll draw some dots up here representing air. And the idea is that it's very difficult to open, so it is difficult to open the bellows. To open the bellows, because opening it would create a large pocket of air under water, you might say, a pocket of air under the water. Now, should we say it's difficult to open this bellows because nature abhors air? Well, no, Pascal says. That's not really a good way of talking about it. It is difficult to open the bellows, but it's not because nature abhors air. It's because of the weight of the water pressing in. And so he uses this analogy to say it's the same kind of thing if we had a very long tube and a bellows like this. So here's another bellows attached to a long tube. Let me draw the ground right here once again. And then let's suppose now we don't have this underwater, but we have it under a sea of air. So here is air like this. This is our atmosphere. And then out here you have a vacuum of space. Okay? And once again, we will find that it is difficult to open the bellows because opening it would create a large, more or less large, pocket of vacuum under the sea of air. So, is it okay to say that it's hard to open this bellows because nature abhors a vacuum? Well, no, Pascal argues. It's not that nature abhors a vacuum. It's that the weight of the air is pressing in on it. So it's no more valid to say nature abhors a vacuum as an explanation for why it's hard to open this than it would be to say nature abhors air as a reason for why it's difficult to open this. So we should neither say nature abhors a vacuum or nature abhors air, rather that the weight of the air or the weight of the water is responsible for the difficulty of opening this. Notice also that we don't actually need this vacuum, this tube going all the way out to space. We could just cut it off right here, seal it, and then erase all of this. So I'm going to, I don't know if this is going to turn out well. So we could erase all of this. Imagine having just a sealed bellows and nothing really changes. It's hard to open this. You've got a vacuum in here. It's hard to open it. It's not because nature abhors a vacuum, but because the weight of the air is pressing in on this, and that's why it's hard to open it. So that's the argument that Pascal uses. So let me go back to the camera here. So that's how Pascal explains the rationale for his explanation of these kind of situations that had previously been attributed to the hatred of a vacuum, and he says it's because of the weight of air. Now, he also goes on to say that there are really three errors that prevented the ancients from recognizing the true cause of these effects. And what are those three reasons? Well, first of all, so I'll go through these one by one. So the first reason, he says, is because air was thought since ancient times to not have gravity or weight, but to have levity. And after all, if people didn't believe that air had weight or gravitas or gravity, then the weight of air can't explain anything because it doesn't have any weight. So the whole idea that air has levity and not weight or gravity is one of the errors, he says, that kept people from getting a correct understanding of these kinds of phenomena, this cohesion of bodies and the difficulty of opening a bellows and so on. So that's the first reason. The second reason is because people thought that elements did not have any weight when they were surrounded by the same element. So for example, if you took a balloon and filled it with water, it has weight. But if you take this balloon full of water and you put it underwater, it was thought that it did not have weight anymore. So objects do not weigh when they're surrounded by the same substance. Pascal says this isn't quite right. In fact, objects do have weight, but the reason why they don't seem to have weight when they're underwater is because there's a buoyant force pushing up on them. So let me draw a little picture here to maybe explain what I'm talking about. Oops, let me go back. Use this and get rid of these two. Okay, so how do we, I'm going to keep this. How would he explain this? He'd say, well, if you have water right here, and we consider a particular region of water that is underwater, well, what are the forces that are acting on this? Pascal would argue that this water still has weight, and the weight is equal to the mass of that chunk of water times g, that's the acceleration of gravity, that's a conversion between mass and weight in, let's say, pounds or newtons. But there's also a buoyant force that is pushing up on it, and the buoyant force is equal to, as we know from Archimedes' principle, the weight of the displaced fluid. So in other words, the buoyant force is exactly equal to the weight of the water displaced. And since this whole thing is immersed in water, that is going to be the same as the weight of the object itself. So the buoyant force in this case is exactly equal to the weight of this object. And that's why it seems that there is no weight that this has. It has no effective weight, you might say. But it's not because the object doesn't have any weight. That chunk of water does have weight. It's just canceled by the buoyant force. Okay, so that's the second error, he says, that led to people not being able to come up with a correct account of these sorts of phenomena. The third one is an error related to this idea that a vacuum cannot be created at all. So for instance, when you try to take a syringe and you pull water up into a tube, so let's suppose you take a syringe with a tube on the end of it and you dip it into a pan of water and you pull it up, the water gets drawn up into this tube with the syringe. And people had been doing this for quite some time, so they noticed that you can draw this water up, 1 inch out of this pan of water up into a tube. You can draw it up 10 inches, you can draw it up 15 inches, you can draw it up 2 feet, 5 feet, and so on. And this water can be drawn up as far as people were aware. It could be drawn up as far as you wanted to, up to 10, 15 feet. And so they were using the principle of induction that if you can draw it up 1 feet or 2 feet or 5 feet or 15 feet, there must be no limit to how far water can be drawn up in a tube. I mean, it's the same kind of idea as if I'm sitting here in my library, I look out the window and I see a bird, and it happens to be a red bird. And then I look out a couple minutes later and I see another bird, and it's a red bird. And I look out again later and it's a red bird. It would be reasonable, using this principle of induction, to say, well, I'll make a general rule that all birds are red. Every bird that I've seen sitting here is red, therefore all birds must be red. So that could be Dr. Keene's law of all birds being red. Of course, that's a valid kind of generalization, but only insofar as it's true, right? So if later on I were to look out the window and see a blackbird, that would foil my entire theory, okay? Well, this is kind of what was happening with drawing water up into tubes. People had drawn water up various distances and found that the water gets drawn up into a tube as far as they know to whatever height they want. And so they came up with this general rule that you can't create a vacuum. The water will just follow the syringe, the plunger up into the tube as far as you want to go. The problem is they just didn't go high enough. And if they had done it, drawn it up into a very, very long tube, they would have found that there's a limit of about 31 feet. And once the water goes up 31 feet, then the plunger separates from the surface of the water and you get a vacuum at the top. In fact, this is something we came across in Galileo's dialogues. You might remember that he mentioned that there is a limit to how high water can be drawn up into tubes. And this limitation, he said he learned about from Italian fountain makers. So the people who are building fountains, probably in Florence or somewhere else in Italy, who are trying to draw water up into very long tubes, found that there's a limit of about 31 feet that the water could not be drawn up any higher. So Galileo, however, saw this as sort of an inherent limit on how well pumps could work. He did not draw the conclusion that it's due to the limited weight of the Earth's atmosphere. And this is the step that Pascal then takes. he says the reason water can be drawn up to only a certain height in a tube is because the atmosphere has a weight that's only heavy enough to push water up 31 feet into a tube. Okay, and what Pascal did is he suggested an experiment to test this, and what he did is he took water and he drew it up into a tube, and he saw how far it could be drawn up, and then he went up into a mountain, the top of a mountain, the Puy de Dôme in Auvergne, France, and he showed that this limit of 31 feet actually depends on the altitude that you're at. So when you go up, let's say 500 fathoms, as he did, there's a shorter height that the water can be drawn up in the tube to. And so he notices that kind of makes sense if you say there's less weight of air weighing down on the surface of the water and pushing the water up into the tube when you go up to a high altitude than when you're at sea level. And so this is sort of the crux of Pascal's argument then. He says if you're going to claim that nature abhors a vacuum, and that's the explanation for the limited height of water, then what are we going to say? That nature abhors a vacuum more when you're in a valley than when you're up on a mountain? It seems like nature is kind of whimsical in that way. So he kind of asks these rhetorical questions. And let me talk about in his text at the very end on page 236. He's using this rhetorical strategy. He says, what? Does nature abhor a vacuum more on mountains than in valleys? Does it abhor a vacuum more in wet weather than in clear weather? Does she not hate it equally on a belfry, in an attic, and in the yard? So he's sort of making fun of people who would attribute nature's hatred of a vacuum, or would attribute these kind of limitations to nature's hatred of a vacuum. So that really finishes the discussion that Pascal had on nature abhorring a vacuum. He says that it doesn't. Now, let me go back to the original question that we had asked. This is the broader question of, is it ever appropriate to speak of nature as having goals or having purposes? Pascal didn't like talking about nature as having the goal or a hatred of something. But as I said before, there are certain parts of nature that do have goals. Insofar as we are human beings and we have goals, and insofar as we're part of nature, then parts of nature have goals, right? So the question is, what parts or what entities within nature is it okay to say have goals or purposes? Or in short, what parts of nature are animate? So today we Christians tend to think of people as animate, right? That's a traditional view. It's also the contemporary Christian view. And you might also say that human beings have souls, okay? Some people will say, well, maybe other things have souls, like dogs maybe, so they can go to heaven with us. That'd be kind of nice, but probably, not cats maybe, or squirrels, I suppose. Definitely not spiders or roaches, But I'm kind of kidding here, but the general view people have is that human beings have souls and nothing else does. And the point is that we are really unwitting inheritors of the position of Descartes. He was a contemporary of Galileo's and Pascal, and Descartes argued that human beings have souls. They are thinking beings, or res cogitans, as he would say. Everything else does not have a soul. There aren't other thinking things. They are merely extended objects, res extensa, to use his terminology, that behave as mechanical devices or machines. So since the time of Descartes, there has been some disagreement about where to sort of draw this line of ensoulment. So let me draw a little diagram here to give you a sense of what I'm talking about. I'm going to save this. I can probably fit this in here. So let me draw some lines here to separate off what I'm talking about. I take it back. Let me just delete all that. Okay. I'm going to draw a diagram here. So if we think of human beings here, so here are humans, and then the things that are lower than humans, we might say, we've got animals down here, and plants, and minerals. And even let's be very general here and talk about, other things that might be above humans, for example, angels or other angelic powers. powers. Okay, and God or gods. Okay, I'm trying to be general, so we're talking about something that not just Christians would be able to talk about, but others as well. And the idea here is that there's sort of a dividing line. Okay, so everything down here in the Cartesian view, or Descartes' view, are machines. Or you might say they're soulless. Okay, everything up here are thinking things, res cogitans, thinking things. Okay, and they have, we could say they have souls, we might say. Okay, and humans are kind of straddling this. Okay, so humans are both. They're thinking things that have souls, but they're also machines. Okay, so they're this dividing line, but everything down here below that are strictly machines, complicated machines, very peculiar machines, but machines nonetheless. And everything up here are purely thinking things, or souls, disembodied, you might say. So one could put the human beings as the dividing point, sort of balancing, as it were, between ghosts and machines. You might think about it that way. Okay. Now, modern man has really extended the mechanical view upward to include humans. So there's really no ghost at all. Everything is strictly machine. So kind of the modern perspective is to, well, maybe we'll just get rid of angels and those kind of things, but even just draw the line up here and say, well, this is sort of the modern perspective, is that even human beings are just machines. So everything is machines. This is a modern perspective. Modern. Okay, everything is just a machine. I know we feel like we have souls, or we feel like we have ideas or goals, but really it can be all reduced to mechanical motions. That's a very modern view. Another view that we could consider is moving the line all the way down here. Okay, and that's, for instance, how Leibniz thought about it. Leibniz came after Descartes. He was a contemporary of Newton's, and he really extended the dividing line downward, and he claimed that all objects, even atoms themselves, are really ensouled, so to speak. Each atom is, he called them monads. I know it's a funny word, but a monad is sort of an elementary being with a non-mechanical nature. Even animals and plants and even minerals or atoms have souls, so to speak. Okay? So I'm kind of giving you a sense of, there's disagreement about where to draw this line between what is a machine and what is a thinking thing or a soul. Okay. Now, I want to highlight something else here. Is there's a traditional view, an ancient view, and let me get rid of this. So the traditional or ancient view, held by many cultures, including the ancient Greeks, and really was maintained through the Middle Ages, is that nature, all of nature, is sort of an ordered hierarchy. Each level of this hierarchy has a different degree of ensoulment, so to speak. And so there's a book called A Guide for the Perplexed, which I think you might find interesting. A Guide for the Perplexed. And this is by an author named E.F. Schumacher. It's a pretty short book, but I think it's a really interesting book because it lays out this traditional and medieval view pretty clearly. And so I just want to summarize what his views are before I finish up this lecture. So his idea, and the idea that, well, this isn't his idea, this is really his explanation of this ancient idea. So the ancient or the traditional view goes something like this. Well, you have, at the bottom level, you have minerals. Okay? And I'm just going to say equals M. You'll see this in a moment. Okay? The next level up is plants. Okay? And I'm going to write M plus X. Let me just make a comment here. So this is sort of the level right here. This is the, you might call this the kingdom we're talking about. The mineral kingdom, the plant kingdom. And over here is sort of the nature of things in that kingdom, the nature or abilities. Okay, so minerals are really inanimate. They're inanimate, maybe you'd say they're passive. They don't have souls, okay? Plants have what was called a vegetable soul, okay? That allows them to grow and to reproduce. So the language of ensoulment extended to plants. It wasn't the kind of soul that you and I would have, but nonetheless, it's some mysterious power they have that allows them to grow and to reproduce, that distinguishes them from minerals. Okay, so they have the properties of minerals, but they also have some extra something that gives them different powers. Then the next level would be animals, which would be M plus X plus Y. So they were said to have a motive soul that makes them conscious. It allows them to move, for example, right? So they had certain properties that were similar with minerals. They have certain properties that made them similar to plants as well. After all, they are able to grow and to reproduce, but they've also got something extra. They're conscious in a way that plants aren't. They can move around in a way that plants aren't. So there's some extra property that they have. And then finally, we have man, or humans. We could call it M plus X plus Y plus Z. And they're said to have a rational soul, okay? That allows them to contemplate. Allows them to contemplate, to reflect, to think about themselves. They have the ability to use language in a clearly different way than the rest of the animals do. So they have certain properties that are like minerals, they're material objects, but they also have the properties that are similar to plants. They can grow and reproduce. They have properties that are like animals. They're conscious, they can move, but they have something extra that allows them to contemplate, to reflect, to use language. So this is sort of a hierarchy of kingdoms or types of entities that are in nature. And notice the notion of a soul applies not merely to man, but to animals and plants as well. There's something intangible about plants that's different than minerals. And there's something intangible about animals that's different than plants, and so on. This transition from here to here is a transition between non-living and living. So there's life added here, right? And you might think about this transition right here as being a transition between unconscious and conscious things. And this transition here is between conscious things and conscious things that are self-aware, are able to reflect. And the important part is there are some clear discontinuities between these, or jumps separating these levels of being. There are certainly some difficult edge cases, right? So, is a coral more like a plant or an animal? There are cases that are difficult to decide, but generally speaking, this sort of classification captures an essential feature of nature. We recognize living things, we recognize life, but we can't create life. And living things are very different, right? Living things are different than non-living things. Living things act in such a way as to carry out or perfect their nature or their destiny.